Hey everyone, welcome back. So this particular lesson, acids and bases. In this lesson, I'm going to give you a brief overview of acids and bases, and then we'll talk about how we can recognize them as formulas, how to write them, how to name them, and then there'll be a more detailed lesson. If you would like a more detailed lesson on uh, all of this, then I can provide one of those, and I probably will. But for now, this is just the basics of what we need to know, kind of the bare bone essentials. And most of this you're familiar with, just some of it will be a little more technical depending on what level of chemistry, or if you're just entering chemistry, or if you're just new to the naming systems for chemistry. So let's jump in. When we're talking about acids and bases, what we know typically we are in a solution. And what that means is that we have compounds that are mixed in some sort of a solvent. Typically, now you can have what is called the dehydrated or anhydrate form. You can have what is called an anhydrate, which means that the water is taken out, or as much of the moisture is taken out as possible, and it would be in a more solid substance, and it would still have its acidic or basic properties. But for the purpose of this video, we're going to assume everything is in solution. It'll make it a lot easier for us to just kind of get started with this. So acids essentially have a higher concentration of what we call hydrogen ions, and bases have a higher concentration of what we call hydroxide ions. And this makes sense if you look at this together. This is H2O. Well, that kind of makes sense. So over here, let's visualize this just a little bit. All right, let's visualize this just a little bit. I'm going to come down here. Do that, something like that. Then I'm going to come up here, do something like this. All right. Things tend to be very acidic or basic, which we also call alkaline. All right, where's my undo button? Alkaline. All right, alkalinity. All right, and I wrote that sideways just because I wanted it like that for a reason. I don't know. To me, just I don't know. I like the way it looks. So with that said, what that means is this: when something is more acidic, then that means that the concentration of hydrogen ions is increasing. And if you follow this arrow, even though it's going downward, it's increasing in this direction. So as we move in this downward direction according to this scale, then we would get an increase in acidic properties. And conversely, if we have an increase in hydroxide ions, then it becomes more basic in nature. All right, and it'll exhibit those. Now, the scale typically runs from 0 to 14, and right in the middle, we have 7. Now, this is actually, the pH and everything works off of what is called a logarithmic scale, and that's going to be the other video I'm talking about, where I'll get more into the basics of that. Here, I'm just trying to remind you of the visual of a higher concentration of hydrogen ions or hydroxide ions if something is acidic or basic. Okay, that's what you need to be visualizing in your mind. And so when we're sort of at a neutral number, a neutral concentration, that would be, we would see that in like distilled water, right? All right, this would have a neutral concentration. So we would have an equivalent amount of hydrogen and hydroxide ions in solution, and at that point we would say that its pH is 7. And then of course up here we have pH of 14, and down here we have pH of 0. Okay, and so you see how we wrote pH and pH. Well, technically, there's not only pH, but there is technically also pOH. And the two of those together, and that'll be the focus of another one, but the two of those together has to equal the total of what you have, both hydrogen and hydroxide ions. And that kind of makes sense. What we tend to focus on is this value here. But if you are a chemistry major, if you're working in a lab, understanding pOH, it's sort of conversely so that if you understand this one, you understand this one. But understanding the concentration of both relative to what's in the solution is very important. For our purposes, we'll be mostly focusing on pH. All right. So with that said, now that we've got a visual of all this, let's go ahead and let's start doing something with some formulas and some naming. All right. So right here, we've got some compound formulas. These are all acids. So what you should notice is that every one of these formulas begins with a hydrogen. When you see that, that's going to be the first thing to let you know you have an acid. Okay. When you see the hydrogen in the front of the compound formula, you are dealing with an acid. All right. So the first one up top, that's pretty familiar to most everybody. All these. The very first one is the most common, most familiar that you're used to. There's two sort of kind of basic rules and understanding that you need to be aware of. So you can see how this one and this one, they don't have, see how there's no oxygen in them. And so when that happens, the name starts out with hydro. All right. And then we add in the name of the anion. All right, we add in the name of the anion. And so for instance, and then we're going to drop the ending and add IC. So for instance, this first one, HCl, that's hydrogen, so we've got hydro, and then there's chlorine, so we would say not hydrochlorine, but hydrochloric acid. The second one here, there's no oxygen there, so we say hydro, and then you see that there's an S, so once you see the S, you realize, okay, that's sulfur, so we go, hey, it's not hydrosulfur, but hydrosulfuric. And then, of course, acid and acid, right? And then we look down. Let's skip this third one. Let's go to this one. We notice, excuse me, there's no oxygen in that either. So we go hydro, and then we have carbon and nitrogen. You have to remember that this is a polyatomic ion. So remember, always go back to your polyatomic ion sheet. And when you look there, you will see that CN, that is your cyanide. All right, you can see if we zoom in, you can see the CN negative. That's the cyanide anion, polyatomic ion, right? And so we would come over here and write, instead of writing hydrocyanide, we would write cyanic. We would drop that IDE ending and put IC. So hydrocyanic acid. All right. So that this rule right here works for this one, excuse me, and this one. All right. So now let me change colors here just so we can I don't know, have something a little bit different just for some contrast for you. So now there's a couple rules to remember. 8, ik, eit, us. All right. So when you have the anion, the negative part that ends in ate or ite, then you drop this ending and you add this ending. So if something were, for instance, if it were to end in 8, then you would drop the 8 and add IC. If it ends in ite, you drop the ITE, and then you just in the OUS. So H3PO3, all right. So H3PO3, we were to, if we looked up PO3, PO3 would be phosphate, right? Oh, I'm sorry, no, my bad. I'm so used to using phosphate. This is phosphate. So PO4, 3 minus, that's phosphate. PO3, 3 minus. Oh, that's pretty messy. Let me erase that for you. But PO3, 3 minus, that's phosphite. And so essentially what happened was we had a hydrogen ion and we had this phosphite ion, all right? And so, and this is a 3 negative, so we would need 3 of these, so that's where we got H3PO3, all right? And so we would drop the 8 and then add I'm sorry, I keep doing that. We would drop the ite and add OUS, right? So this would be phosphorus acid. Okay? Phosphorus acid. All right. So now let's look at this one right here. We see this CrO4. Well, let's go to our chem equation sheet. And we see that CrO4, 2 minus, is chromate. So we're going to come back here. Let's erase this part here. All right. And so we've got CrO4, 2 minus. That obviously was added to hydrogen ions. So what I've done last time and this time is I'm just drawing out like a net, a basic balanced ionic equation so we can see how the ions are combining together. So we needed 2 of this to balance it out, right? So that's where we got H2CrO4. But remember, this was chromate, so we drop the ending and we add this IC to it, right? And so we would get not chromate, but chromic acid, all right? And so those are the 2 rules. You're either going to have this rule here or you're going to have this rule here when it comes to naming your acid. So the question is does it contain oxygen? If it does, you're using this set of rules. Does it not contain oxygen? Then you're using this set of rules. That's pretty much basic. That's straightforward right there. All right, let's move on to another little example. Let's go ahead and let's write the formulas for these right here. So we have sulfurous acid, right? So we see it ends in OUS. So remember, 8 ic ite us, right? So sulfurous acid. Sulfurous must have meant that it ended in ITE. So we must have had sulfite, right? And sulfite is SO3 2 minus, so it must have been mixed with the hydrogen ion. So we know we would get H2SO3 for the formula. All right. Then we've got, so it says nitric acid. It ends in IC, so we must go with the 8. So nitric, if we go backwards, then that must have been nitrate, right? And nitrate we know is NO3 negative if it's combined with an acid, or with hydrogen ions. So that's where we would get HNO3 for our formula, right? Acetic acid, right? Acetic acid. So ends in IC, then we must need the ATE. So there is a polyatomic ion, acetate, right? C2 H3O2 negative. This is an acid. We can see that there's a positive 1 charge and a negative 1 charge, anion charge. Those already equal 0. So this must be HC2H3O2. Okay. Now, hypochlorous acid. So hypochlorous must have meant that it ended in ite. So there we go right there. We've got our hypochlorite. And if you're not sure, all you do, remember, you go back to your chem equation sheet. Let me get this off of here, right? And then there's your hypochlorite right there. And so, your chlorate and chlorite, essentially, the way this works is you can see that it goes from 4 to 3 to 2 to 1. So 8 is usually the higher number of oxygens, and 8 is the lower number of oxygens. And then hypo just means less than or under. So hypo right here would be even less than the 2, which is the 1. And the perchlorate, kind of this with the per, that means it's going beyond that. It's outside of that. So we would go from the 3 to the 4. So that's why that's why it's written in these orders. So that naming system makes sense based on that understanding. But we're dealing with hypochlorite, ClO minus, right? So we've got ClO minus plus our hydrogen ion. The oxidation charge sums are already 0 by adding those together. So we've got HClO. All right. And then perchloric. So there must be something here that is that whole per. We just saw that a second ago. So that whole perchloric. So that would be this perchlorate right here, correct? So we go back to the perchlorate and we see that it's ClO4. We saw that with a negative symbol. Plus our hydrogen ion, right? Let me get this out of the way for you. And so you can see the sum of those oxidation charges is already 0. So we've got HClO4. All right, that's pretty straightforward. Let's take a look at bases real quick. Bases, so remember, with bases we're dealing with an increase in hydroxide ions. So this is your anion. So we're going to combine cations with this. So let's just go to the periodic table. And go to the periodic table. Let's just take something from here or here. It doesn't matter. We could take any metals. It doesn't matter. But we'll just typically go with these right here. These are what you're working with. We could go with sodium or calcium or barium, for instance, right? So sodium we know is Na+, and we would combine that with the hydroxide ion. The sum of the oxidation charges already 0, and so that would be NaOH, and so we would literally call this sodium hydroxide. So I know you saw that flash across at 10% low battery, but I've got plenty of time on my iPad to get this done. Then let's go with barium. That was one. Barium is a positive 2 cation. Combined here. For this to balance out, we would need 2 hydroxide ions. So there's 1 barium, 2 hydroxides. There's 1 hydroxide. There's 2. So you should remember that when you're writing these particular type of compounds with polyatomic ions, that when you have multiple polyatomic ion, it has to be in parentheses before you add the subscript. So this would obviously be called barium hydroxide. All right. And if we had something like iron, right? I'm just making stuff up at this point. So right, so you can see that we would need 3 of these. So you would have iron, and then you would need 3 of those. And then the reason why I picked this one is just so we can very quickly remember that we need, since this is a transition metal, we would have to say iron 3 hydroxide, because you need the Roman numeral to represent the charge on the cation, on the positive ion that is in solution, that's in there, or in, with the compound. And then that's it. That's pretty much acids and bases. A little overview of what they are, and then how to kind of name them, how to write the formulas. Pretty straightforward. Glad you were here. Go do some of those practice problems, problem sets. Get with me if you have any questions. Always good learning with you. Stay curious, and I will see you in another lesson very soon. Bye.